Hello friends, before we move on next topic, let me solve one more example. This is given example. Determine the internal shear and momentum acting at a section passing through point C in the beam shown. So I have to determine shear force and bending momentum at point C. For that I have to choose only one section, that is CB or CA. It is easy as compared to CB if we take CA. So we will choose section CA, but for that here at A there is a pin support. So first I have to find support reaction at A, because then I can use this and find this in this shear force and bending momentum at point C. Let me first support reaction at A. For that I have to consider this whole structure. So first I will draw free body diagram of this whole beam. As you already know, it is very easy to find. This is a pin support, so this will give two reactions, support reactions. One will be in vertical direction, I will write it as AV, and one will be in horizontal direction, I will write this as AX. This is point A and this is point B. This is also a pin support, so this will give also two support reactions. One will be in vertical direction, that is BV, and one will be in horizontal direction, that is BX. And this is loading, so I will draw point load in place of this uniformly varying load. So this will be area of this triangle, that is base is 18 into 3, this is 27, and this will be at a distance of this 18 by 3 from the support B. So I will draw here 27 kilonewton, sorry 27 K, and this distance is 18 by 3 from support B, because this load will act on the centroid of this triangle. So this will be 18 by 3, that is 6 feet. Now we can find the support reactions. First I will make one equation, that is summation of vertical forces equals to 0, but there are three vertical forces AY. I will take upward direction as positive AV plus BV, and downward direction as negative minus 27 equals to 0, which further implies AV plus BV equals to 27. This is our first equation. And second equation is, I will use this equation, summation of momentum at point A is 0. So I can write summation of momentum at point A is 0, that is due to this force and this force, it is 0, these are passing through this point. So I will write due to this force, it is trying to downward beam in downward direction there. So this momentum due to this force is negative minus 27 into distance is 18 minus 6, that is 12, plus due to this force this is positive, this will try to rotate beam in upward direction. This is BV, and distance is total 18 feet, will be 0. Due to this force, this is also passing through the central point, so due to this force bending momentum will be 0, which further implies BV equals to 27 into 12 by 18. So BV equals to 18 K. So our PV is 18 K and AV is 27 minus 18. So I write 27 minus 18, that is 9. So our AV will be 9K and this will be 18K. I will write here 18K. Now I will use this. I will take this section A and C. Now I will take this section here. This is A at And this if you try if you find ax and bx, you can write here summation of horizontal forces equals to 0. That is, I will take this direction as positive, so you can write bax minus bx equals to 0, or which further implies ax equals to bx. But there is actually no any horizontal force, so horizontal forces will be 0, ax will be equal to 0, which is equal to bx, because there is not a single horizontal force. Now we will take this section, and at point A we find here is support reaction 9 kilonewton, sorry 9k. This is point C. Here will be bending momentum, because we are this yes we are breaking this beam, so this is fixer. This is one type of fixer here at C point, so this will give three reactions: momentum at C, and this will give one reaction or vertical reaction. I will write this as CV, and one horizontal, I will write this as CX. There is no any horizontal force, so CX will be 0. If we will neglect it, it is. Now at this point C, I have to find load. So we can, this is 6 feet distance between these two is 6 feet, so we can use similarity between two triangles. So I can write this is a section AC. I can write this 6 by this total distance 18 equals to x. I will write it as x by this total force here, this is 3, because this is by the property of similarity, ratio of all corresponding sides of a similar triangle are equal. So I can calculate here. From this I can write x equals to 18 by 18, that is 1k. So I can write here, this is force 1k per feet. Now I have to first draw free body diagram for this section. Now I will draw free body diagram here. I will write here 9k, and here I will write CV, and I will write here momentum due to point C, and this is 6 feet. This I will write this is a uniformly varying load. I will write point load in place of this load. So this will be at a distance of 6 by 3, that is 2 meter from support C, and it will be area of this triangle, that is base into altitude by 2, that is 3. So I will write here 3k. Now this is free body diagram. Now we have to find MC and CV. For that, let we take summation of momentum at point C equals to 0. So I will take summation of momentum at point C will be 0. So I can write, due to this force, this is trying to rotate beam in upward direction, it is 9 into distance. So this is total distance is 6 feet, and this is 2 feet, this distance. So I can write 9 into 6. This will try to rotate beam in downward direction. I will write minus 3 into distance is 2, and this is also trying to rotate beam in downward direction. I will write MC equals to 0, which further implies MC will be 48k feet. This is MC. Now I have to find this CV, vertical force at point C. So I can write summation of vertical forces will be 0. So I can write here vertical forces is 9 plus CV will be equal to minus, sorry, this is 3 k will be equal to 0. I treat upward direction as positive. So 9 plus CV minus 3 will be 0, which further implies CV equals to 6. CV equals to 6k. Sorry, this is minus 6k. Here this CV comes out to be negative. It means our assumed direction is wrong. So we have to take direction as this, as downward direction. Thanks. Hope you understood this.